Hi everyone, this is Lydia with what I wish they had taught me about econometrics and introduction. In the previous videos, we have seen the proofs for the OLS formulas for our beta coefficients, beta null hat, and beta 1 hat. I showed you the math tricks behind it, and the operator that we mostly used was the summation operator, and the properties of the summation operator are quite important. That's why this video is going to be dedicated only to the properties of the summation operator. So for those of you who found it difficult to follow those videos, although the reminders were quite short, this is the video to get you to know a bit better with the summation operator and how we use it. So keep in mind, the summation operator, we're most of the times working with a variable, let's say xi, and in here the I is usually a counter that goes from 1, 2, 3 until, let's say, n, whatever is the maximum amount of numbers that you allow in a particular sequence of values for your variable. Okay, so that means that, again, if we have the sum for a counter that goes from 1, let's say, to 3, for xi, that means that you simply have x1, because this is what happens to your element whenever the counter takes a value of 1. Then the moment that you jump on the second counter, I equal to 2, now you have x2. And the moment that your counter increases again by 1 and you have I equals to 3, then this is your x3. Okay? If you have longer counters, so you got 1 to n, xi, then we generally write it as x1 plus x2, and then 3 dots here to say this continues until xn. Okay? Now, let's move to the first property that would relate to the constants. And we've seen this being used quite a lot, especially in the proof of the first order condition with respect to the beta 0. So for any constant, let's say C, but keep in mind, a constant, you can give it any name, A, B, and so on, as long as you mention that this is a constant. In this case, I'm just calling it C because it just makes very clear sense, like, or a relation directly to constant since it starts with the C. So again, if I have any constant, and let's say an operator that goes from 1 to 5, what I will have is simply on the first loop, on the first jump, I'll have the C, simply a C. There's nothing for me to substitute in there in terms of the I operator, because I don't have an I anywhere on this constant, okay? Then I need to jump on the second loop, so that again is another C, and then on the third loop I have another C, and then again on the fourth loop I have another C, and on the fifth loop I also have another C. So as you can see, I have as many C's as loops, as jumps that I have on this counter, so this is just going to be 5 times C. So more generally, then this translate into the sum from I to n on any constant is just going to be n times C. Okay? Now, what if we change it a little bit? What if instead on my loop earlier in here, what if I had Ci from 1 to 5, C times Xi? Okay? In this particular case, I would have on the first jump, so when I is equal to 1, I will have the C, which doesn't change, but xi becomes x1. Then when I move to the second jump, so on the loop, I will have C times x2, because the I, again, is the only thing that can be substituted. And then I can continue this until C times x5. It's very clear that the C is the same in every element of this sum, and I can I'm actually going to move into a new line in here so that I don't have to squish it. So that means that by factorizing the c, I am literally left with x1, x2, until x5. And ultimately, if you think about it, this is just the sum of xi, which is the formula that we saw more generally up here like this. So ultimately, what I have is that this is c times the sum for I from 1 to 5 of xi. More generally, okay, it means that whenever I have the sum for I from 1 to n of c times xi, that is simply n times, that is simply c times the sum of your xi for I from 1 to n. Okay? Now, you might see this with more complicated expressions, not necessarily in the derivatives exercise, but other types of proofs within econometrics. So in this particular case, let's say on top of xi, imagine that we also have a yi, and imagine also that we have two constants, a and b. Okay? What if we had the sum of axi plus b yi? How do we apply the summation operator in this case? Well, normally, if we want to split it, that would be just axi plus the sum here b yi. And let's put 1 to n, 1 to n, 1 to n. For each of these elements, then we can apply the formulas, like the properties that we have just seen, which means a being a constant and b being a constant can simply jump right in front, and we can rewrite it simply as a times the sum of your xi, I from 1 to n, plus b times the sum I from 1 to n of yi. Now, this is where the property actually finishes, but keep in mind, you have seen this even in the derivative exercise in a slightly different version, because what you would have done in the derivative case for the first order condition of the OLS is that you would have used the property of the average, so the formula on the average, where you know that the average x bar is actually the sum of all of your xi's 1 to n divided by n. So from here, you could have expressed xi, the sum, simply as n times x bar. And in those previous videos, as I said, you will have seen this as a times n times x bar plus b times n times y bar. I hope this was helpful to refresh a little bit your knowledge or on the summation operator, and I'll see you in the next videos.